Welcome, listeners, to the Dino Podcast. We have a special guest today to talk about technology. Specifically, we're going to cover large language models and how they are potentially impacting the core job of software developers. We'll talk about the state of the software developer job market today, and we'll dive deep into computer science education, specifically with an eye towards what skills will be valuable now going into the future in a world where large language models are part of our tool set. To help me with this conversation, I have a special guest. He's a technologist and a legendary computer science educator in New York City. He has industry experience at Goldman Sachs and Google, but ultimately his journey took him into computer science education. For over 20 years, this guest has led the computer science department at Stuyvesant High School, one of the very best math and science high schools in the country, and he's been referred to as the godfather of computer science at Sty. Many of his students have gone on to have amazing careers across the tech industry. And as a fun fact, he was my teacher in my own very first computer science class. So please welcome to the Dino Podcast, the godfather of Stuyvesant computer science, Mike Zamansky. Mike, welcome.
Hey, thanks, Dino, and thank you for all the kind words.
My pleasure, godfather.
But you come with me, but you don't show respect. No.
This is going to work great in our New York themed Bodega Corner segment later. Mike, let's start with your own story and your own journey. How did you get into computer science, and then how did that journey ultimately take you to becoming a computer science educator?
Well, it's funny. One thing I wasn't even thinking about, and it just popped into my head now, which I think is really relevant to the job market today. I was always interested in computers, but I grew up in the 70s. I went to high school. I graduated high school in '84, and I recently retired. And we had a little retirement ceremony, and my oldest, dearest friend was saying about how he met me, and that he found out that I was into Dungeons and Dragons. This was, first generation Dungeons and Dragons. Like, oh, cool. And then he found out that I was into computers, and he's like, wow, I found the other guy who likes computers. And it's like, that's the different world. I mean, it's like, even into high school, and I went to Stuyvesant as well, there were only a handful of us who had any interest in computer science or computers, because what did we know from computer science? As opposed to what we're at today, but I'm sure we're going to circle back to that when we dive into the core topic. But I was always interested in computers, but I never really, never thought about being a teacher, going into education. So I went to college, studied computer science, worked my way through school. So I ended up running the computer facilities for NYU's business school, undergraduate business school. Mm-hmm. Ended up at Goldman Sachs for a while. That wasn't doing it for me. The technology, Wall Street didn't do it for me, and I wasn't doing that much interesting in technology. So I wanted to try something else. Did a little consulting for a short bit, and then I just tried the teaching. Just kind of, my mom was a teacher, and I was mostly raised by my mom. My dad died when I was really young, so she had a big influence on me. And teachers were my male role models up until then. So I dove in, I became a math teacher because there was no computer science back then. Managed to transfer to Stuyvesant a couple of years later, and started teaching, basically math. But it worked pretty well, and I figured this was my career. But I was able to weasel my way into CS because the guy teaching like the one CS class there didn't want to do it. And he was a great math teacher, but he just didn't want to do the CS, and I wanted to. And then it just kind of, and it's funny because I'm like, okay, great, I'm teaching CS. I'm teaching 4 classes of CS and 1 of math. And I'm like, I don't really want to teach math. I got to make up a new elective so I can stop teaching math. And that's literally how the ball got rolling. It was like to get out of having to mark geometry proofs. And that's the whole reason why Stuyvesant developed the CS program, purely because I was like, that is so miserable. It's like the worst of grading an English paper and a math test. You put them together. But I talked to the guys, the class, and hey, you guys want to take an extra course? And they're like, yeah, let's do it. How about a graphics course? They actually stayed after school to take the course. That was going well. A few years later, I had this epiphany because my kids were doing great. I have a kid come in top 5 in a world competition, top 10 in a world competition. And I'm like, I'm doing really good. And then I realized that, well, this kid also was on the world math team. He'd probably be okay without me. So I started to look at what I was doing, and that kind of made me reorient myself to well, what about everyone else? And that's when I created my intro course, which really exploded things at Sty. Certainly when it became a requirement, that also got me into the greater computer science education ecosystem, whatever movement, which ultimately led to the CS for All effort in the city and a lot of the CS for All movements around the country. Since then, I spent 25-ish years at Sty in public education at high schools. But then I moved on to Hunter College, where I taught teachers to teach computer science, but I also developed an undergraduate honors program, to kind of be a cheap alternative to NYU or Columbia, both of which are great, but crazy expensive. So the cool thing is, over my career, it's I'm one of the few people who's gone. I've also done work with elementary school kids and teachers, middle school, etc. So I've gone from the grade school all the way through high school into college and then into the workforce. And one of the things that's really informed me, which I also just it feels worth mentioning, is so many of my former students are now in industry. I think it's employee number 12 or number 16 at Facebook was one of mine. The founders of DigitalOcean were my former students. Whole number of CTOs and whatever. But that's also really informed me in terms of what I need to do to prepare my kids so that they can, take the next step. So that's kind of a little bit of a long, the short version. Sorry, still probably too long, but how I got to where, but never meant to be. It was just kind of one thing led to another.
Well, that's fantastic. On one hand, I think it's pretty funny that the genesis of the computer science department at one of the great math and science high schools in the country is that you didn't want to teach and grade geometry anymore. And on the other hand, it's amazing just the students that you've had come through your program and what they've gone on to do. And I think it really adds to the whole Godfather ethos that you have as a New York City tech educator. A lot of those students now are in industry, and the industry's gone through some pretty big changes over the last 10 to 15 years, where I think it's fair to say there's been almost like a gold rush in tech and in software developer jobs, accelerated and turbocharged, especially post COVID-19 pandemic. Um, that's slowed down considerably since, call it, mid 2022. And I'm going to share my screen here to just show you one chart. This is actually a tweet by notable technology commentator Dino Podcast. That's me. But here you can see a chart of software developer job openings in the United States, and this looks like a period of about 4 years. You see a big run up during the COVID-19 pandemic, and then a return to more normal levels. And I imagine this 100 base is pretty high, like it's already an incredibly high level, but we have come down significantly off the peaks. So can I ask you, how do you see the state of the job market today for someone who does computer science, and how have you perceived the journey for developers in the job market over the last 15 years, and then most especially these last 3-4 years of roller coaster ride.
It's there's a lot of pieces in there, and we're kind of, I think, with the I was going to say crash, but I don't really like that term. With the downturn of the job availability in tech recently is kind of a perfect storm, of a confluence of a number of things. Obviously a big, you know, we've had these cycles before. I mean, we had the first tech boom, in the late '90s, where CS wasn't on everyone's lips, but that was the hot field for a short period. Everybody was hiring. Everyone was making these applications that didn't do anything, but it's okay. We'll make up for it in volume. But they never. But then that crashed, or that bubble burst. And then the next one was sustained for a significantly longer time. And then a lot of that was the development of Web 2.0, if you would, and the internet explosion, which really was it was a unique situation in history, because every business in the world now had a new platform to get on. So
Right.
that means a business, it's not just like normally that doesn't happen. It's not like, there might a new sector, like the automobile industry came into being, way back when a new industry was created, but that it affected a lot of things, but it didn't affect everything, but the internet affected everything. It made job opportunity, like every company, like the jeweler down the street now would eventually have to hire somebody to make their web presence and their web store, and we got all of this explosion of companies that, they would say that they were tech companies, but they weren't. They were really web companies. They didn't do anything radically different. It was a strong web presence. Was Warby Parker really a tech company? It was an eyeglass company that leveraged tech in a different way.
Sure.
More power to them. Nothing, but it wasn't like they were pushing the boundaries of the technology. And so that created all these opportunities and the hype, and then we get, we got the CS for All movement in the schools. Everybody has to learn how to code. Like Rushkoff wrote his book, "Program or Be Programmed." If you don't know how to do it, you're going to be victim to this. And everyone got on board. And that's created a huge capacity problem, incidentally, in the colleges, where they just don't have enough faculty to teach. The demand for computer science is through the roof. But this isn't the first time. Back in my day, it was the MBA. And everybody, who didn't know what they were going to do stayed for their MBA or went to get their MBA because that's what you did. 2 or 3 years later, it was become a lawyer. There were actually a couple of teachers at Stuyvesant, at least one of them, who were lawyers, who were like, they got caught up in all my friends are becoming lawyers and I don't know what to do. And they became lawyers, they went to law school. And, one of them in particular, he was not happy being a lawyer, and he turned out to be like the best math teacher ever. Like, he's the teacher that I aspired to be, he was and is amazing. But he went to law school.
Sorry to interrupt, Mike. There's a great scene in The Simpsons where Jimbo tells Homer, "I don't believe in nothing no more. I'm going to law school." And Homer looks at the sky and screams, "No!"
Oh, yes, I know.
You let me down, man. Now I don't believe in nothing no more. I'm going to law school. No!
Exactly.
So there was that time, there was that phase.
Yeah, but that, and now that's computer science. Right. So part of the problem is we have an oversaturation, and that was hurt by, like Ruby on Rails kind of hurt that. If you remember, Ruby on Rails was a platform by which you could pretty quickly and easily turn out a specific type of web application. that was
Mhm.
good for a lot of companies. Basic web store, website presence, simple database backend. That's really opened the door to code schools as well. But that led to a saturation, or an oversaturation of everybody coming into CS. There's huge amount, but even then, it wasn't as much of a buyer's market for the employee as it seemed to be. I was talking to a friend of mine who he spent a lot of time he was a high up at Morgan Stanley, then at Google, then went to another tech company, and I was talking to him about internships and and about return rates, and he was always at companies that only took people from the Harvard, not the Harvards, because Harvard didn't have, yes, they would take Harvard, but it was like MIT, Stanford, CMU, the usual suspects. And I'm like, well, what's the return rate? Because, I knew from my Stuyvesant kids, and the return rate for an internship for a kid who graduated Stuyvesant is like, it's not a question. You get the return offer for your job from the internship. If you don't, something's wrong. And he's like, no, the industry wide, it's like, and I forget the number he gave me, but it was below 50%. Interns getting return
Wow.
job offers at the more competitive companies. So
When was
even
that?
then,
When was that, if I may
that
ask?
was a couple years before COVID.
Okay.
So 2018, 2019, when it was still, when companies like Google and Facebook at the time, before they changed to Meta, had money to burn. Like they were just like, they're printing money practically. But still, so we have that glut of the market shooting up. And a number of things happened, and I just want to mention a couple of them that I think happened even prior to. I don't think the downturn is because of things like AI and large language models. I think that we were well into the downturn. Prior to
Sure.
that, I think it's going to change things. But like Elon Musk was a friend of mine said he's at fault for this. And basically because he fired everybody from Twitter.
And it still worked.
And it still worked. And maybe it didn't work so good, but it was still working, basically. And then at the same time, or a little bit before, there was an article printed about Google about these staff programmers, which is like the highest level you can get, and they weren't doing anything. Like they weren't being productive at all. They were given too much freedom, and so there was this idea of like, well, maybe we shouldn't be, maybe we should have more accountability on our employees. Musk showed that, and again, I don't know if it's true or not. Again, a friend who I respect greatly posited it, and it certainly could be, that we could cut corners, and I do think there's something to that. Because if you remember, during the great purge of a year or so ago, or maybe it's 2 years ago now, that Google laid off a boatload of people, but Google did not lose money. Their profit report was that they made less of a profit. So there's a quote correction that's killing and hurting a lot of people. But a lot of it, I think, has to do with this need for turning more profits every quarter. I mean,
Right.
Google could have taken a slightly lower rate of profit and not laid off all those people. So but
I'll jump in here to agree with you. I think what's really driving some of the downturn in the job market is what's happening from the perspective of the ownership of these companies and the managers of these companies. And there's been this almost like perspective shift away from growth at all costs and an arms race for talent, and almost every single project gets funded and gets the team behind it, versus now companies are really emphasizing we need to generate profit and we need to generate more profit.
right,
Some
yeah.
So
Yeah,
sorry,
and I
go
think
ahead.
it's even from when I was, at Goldman, you could see the seeds. I mean, not of the profit side, but but I think there's something flawed in our, in the mindset of so many companies. I was talking to somebody who's a senior engineer, and really good, and she doesn't want to be promoted to the next level of engineer. Because she doesn't want to do the things that the next level engineer has to do. It's a slightly different role at their company. It's like, I just want to be the best engineer at my level as I can be. And that reflects something of a friend of mine from back at Goldman who said the same thing at Goldman. It's like, like everybody, like everyone at Goldman has to be on this path to be a leader. And it's like, I don't want to be a leader. I just want to be on the team. And I want to be the best person I can be on the team that my leader can rely on. And I want to be well compensated for that, but our mindset, is, you always have to take the next step. You have to move to management. You have to, and it's, whereas there are a number of people who are like, no, I want to be good at what I do. I want to be productive. But I also want to have a work-life balance, and so I think this, I think it's, the worst aspects of capitalism taken to an extreme. That it always has to be more, profit, me, not you. And I think that's unfortunately not healthy. But I think in terms of like getting to where, I think all these things combined, too many people in CS, which will eventually correct it. When I say too many people, I'm not like, we needed to widen the pool, and we still do, because there are all these underserved communities that don't have access. There are, like, if you look at the, like, man, woman, male, female ratios, they're horrible. If you look at, people of color, if you look at Black engineers, they don't have the opportunity. So yes, we have to get a lot more people in to make it equitable and fair. But not everybody's going to be happy being a software engineer, and they shouldn't go into it for the wrong reasons. They got to be exposed to it. They got to know it's for them, and I think right now we're at that stage where it's too much hype combined with, what we both are saying on the company's ends, pulling back. And that's creating a very rough experience for young aspiring technologists.
Right. Yeah, I think the companies are pulling back. Like the emphasis on profit. On one hand, I agree with you that like profit is not the end all be all. The whole like capitalistic approach to structuring a society is not, like the most fulfilling way to find meaning in life. On the flip side, I think like we did have like an experience for a long time where companies almost tried to follow the Amazon playbook of growth at all costs and just invest a ton of money and capture the market. Eventually you'll win and you'll dominate the market and you can turn on profits later. And that led to a lot of companies just sinking capital into a black hole. So I think there's less wiggle room for that path now. And I believe what's driving some of the softer job market is that companies in big tech that potentially overhired for their needs and for the projects that make sense have had to unwind that, and it's been painful for participants in the market. But still, the long-term trajectory, I believe, like what I've seen before, is the demand for software developers is greater than the supply. And like personally, I think that'll continue to be the case.
Yeah, and I think it's gonna. I mean, I think it's gonna bottom out. I think it already has in certain cases. Like, like some of these big tech companies, like laid off all these people, and then a week later they were hiring people again. And so I think it's going. And then what's going to happen is it's going to be the same thing. They're going to prisoner dilemma each other. They're going to defect. Like, oh wait, look, Google is doing this. Meta, okay, we're going to up the. We're going to hire more. We're going to up the benefits package, and they're going to start the race again. And it will be cyclical to a point, for better or worse. At least that's my suspicion. Even with the AI changes, which I don't think, I think it's going to change the market and it's going to change how people prepare, but I don't think it's going to, it's not, I think the doomers who are like, no one has to learn, how to be a programmer or a computer scientist anymore. Yeah, it's a little bit overblown.
I'm glad you brought up that saying because I'm going to put something on the screen. And this is a quote from the CEO of NVIDIA, which is basically to that effect. Here we go. Where he said, it's our job to create computing technology such that nobody has to program. And the programming language is human. Everyone in the world is now a programmer. So I can see why he might have some sort of self interest into hyping AI, which his company is making loads of money out of, and building that hype about like no one needs to program, and now you can just prompt engineer and enter questions into chat GPT type applications. But let me ask you, like, how much have large language models like ChatGPT impacted what it means to be a software developer and the productivity of a software developer?
I mean, I think it's definitely affected things, but it's I ran a panel a few months ago. It was a general audience panel on the current AI. Actually, as a friend of mine who I respect greatly said, the current AI fad. And I loved his choice of the word fad. I think it's a little overblown. I think it's a little bit more significant than that. But I love that he was kind of bursting the balloon a little bit. But on the panel, I had a couple of founders of AI related companies, a longtime big tech person, and then I also had somebody there who was very big in the with the ethics piece. But one of the founders, he said something that I love. That it's like it's just the next thing, and not meaning it's like the next great thing, like the wheel, but it's like it's the next technology that we're adding. Back in the day, like we had the blockchain for people who chased that in Web 3.0, and that was their next thing, and people are off doing their thing there. And he pointed out that it's like still human costs for a company, or that's the greatest expense. You still need quality engineers, but the experience, But I like that thought that it was not that it was like this magic thing. It was just it's the evolution of an industry. But if you think about it, it's an abstraction. It's the next abstraction. So um, when we started all of this before my time, we were programming in machine language, and then the higher level languages came in, like Fortran and COBOL, then structured programming in languages like Pascal, and then object oriented programming, functional programming, and each of these made it easier for us to do more complex things. And for a long time, like so, for example, if you made a very early user interface, you would have to literally draw the dots on the screen. And everything, there would be no such thing as a button, or a text entry field or a drop down, and you'd have to program everything from scratch. But at some point, they came up with libraries for this. So in You Can Code, the person writing the program can say new something. Login equals new button and give it certain properties. Like when you click it, do this, display this, etc. And if they didn't remember exactly how to use it, they would look it up in a manual. And then later they would look it up online somewhere. And then they would get IntelliSense, which is the step before the LLM stuff, which would then give them, the autocomplete. So when they started to type button, it would bring up information to say, oh, here are the things that the button gets. But you still needed that programmer to know you needed to make a button for this. I'll get to a better example in a second. But now with the AI, you can specify more complicated things. And a great example of this is I was talking to another software engineer a little while ago, and this is somebody that I've talked about, joking about how you never need the data structure stuff that you study in college once you get by your technical interview. And they said to me, it's like, guess what I did today? And they ultimately implemented an algorithm, a certain type of a tree search algorithm, a tree being a data structure, a hierarchical data structure. Think of like a family tree where data is placed in various points, and you want to be able to efficiently get to certain places. And this person works for a big tech company and has been there for a while. And they implemented this algorithm, and it was like we were joking about how this was like something from the data structures class that they then had to solve. And then I'm like, but did you actually code? And they're like, no, I just used our internal LLM to generate the code. But they still had to say, I need this algorithm on these parameters in this way. And they still had to verify that it was correct, and they still had to tweak it to customize it for what they needed. So it increased this engineer's productivity, but this engineer still had to know their stuff. And I think that's really, like, contrast that with, I was talking to, this was back in my Sty days, I was talking to a guy, a senior guy, relatively senior, not super senior, at Morgan Stanley. And we were at an event because I had a mentorship program with Stuyvesant students and Morgan Stanley people. And he just came in looking horrible. And I was like, oh man, what's wrong? Like, I'd say, like, you need a drink, but we can't get a drink until after we finish this event with the kids. And he's like, yeah, I was interviewing all day these kids from, and I'm not going to mention it, but it's one of the reputed top 5 computer science schools in the country. And they don't know anything. And I'm like, what are you talking about? They're from this great school. It's like, I asked them these problems to solve that are actually pretty simple if you understand these underlying algorithms. And these are things that my engineers need to know. And none of them could answer the question because they only knew how to use the built-in library calls. Like, they didn't actually know the underlying logic behind it. And so on the one hand, I see that the LLMs, if you know your stuff, can really increase your productivity. But it's got limits, and you still have to know what to ask for. Even if you're doing like a generic-y application for the jewelry store that I mentioned earlier, is it going to be right for that jewelry store? You're going to still have to verify it. You're still going to have to customize it. It's going to be that enhancement, but except for in very rare cases, I don't see it being a replacement. And I certainly don't see it getting to new frontiers.
Okay, so that's helpful. So to round out the productivity point, as a first step, you see it more as like it might give you like a 10% productivity boost, but today it's not creating 10x engineers that are 10 times more productive than they would otherwise be.
And it might be more than 10%. It might be a much larger percent. I think it depends on the engineer. Like, it's not going to, it's not going to design the next whatever big thing is, but it's going to speed up your development of a lot. Like, I've been using Duolingo recently, to try to, better myself and be less pathetic as a monolingual, New Yorker. And it's not going to come up with that, and it's not going to be, you can't be like, make me an awesome language learning app. And it's not going to be able to do anything at all like the way Duolingo does things and the way it intersperses different types of questions and the way it presents them in a particular way, because none of that existed before. And the AI can't build that,
Yes.
because, but for every individual piece in there, the engineer that's pounding away on the keyboard, they're going to get they could potentially get a big boost. Again, I don't really want to say what the percent is because, I've heard people say 5-10%. I've heard people say like 50%. I've heard, but it's a boost. In no cases has anyone said, wow, it did what I could have done.
Right. So I want to talk about, like, now that this very powerful productivity tool exists, what's useful for the engineer to learn to, like, stay on the cutting edge of creating things. But to round out the point on the productivity impact and the economic impact, so there are some productivity gains. Do you think that these large language model co-pilots and productivity tools are contributing to some of this job market slowdown that we saw on earlier charts? Like, are tech departments across corporate America asking, hey, do I really need a team of 50 software developers to do this? Or can I get by with 30? Or do I need to buy these 20 software as a service tools for my team? Or can we accomplish some of this functionality using very widely available commodity large language models as a tool? Like, is it
And
contributing in your view?
I mean that's it's isn't this a case of like perception becomes reality? Like I think it's definitely affecting it, but I question, and I'm not. This is something that I'm not an expert in because right now I'm not in those companies, and but
It's a podcast, Mike. The not being an
yeah,
expert has never stopped me from commentating
hey,
on
okay,
anything.
well, but if you think about somebody hiring is certainly I do think people are saying, do I need 10 engineers? I can get away with 5 and pay for and I think that's perception. So I think it's affecting it in that way. I doubt it's reality. Yeah, because I think generally speaking, there's a great book. It's really on management. It's called The Mythical Man Month, and it's by Fred Brooks, who worked on developing the IBM 360 operating system way back in the day. And the whole idea of the Mythical Man Month, the idea of Man Month is the amount of work a man can get done in a month. And the mythical part is, you can't just hire 10 people and it'll be 10 times as fast. That it doesn't work that way under any circumstances. It's a wonderful book. I think anyone in management has to read it. It's old, but it's brilliant. But and I think that's the case here. Like if you're hiring for your team, if you're using those tools, that engineer is going to move more quickly. But you're still going to need the number of engineers to spread across whatever the roles that you have are. You're not hiring 2 engineers to do the same thing at the same time to be more efficient. You're hiring 2 different engineers to do complementary things. And then the AI will make both of them more efficient.
Sure.
So I think the perception is it's affecting things, or rather it's affecting things because of the perception. But I think people are going to find that the reality is if you need 3 engineers, you need 3 engineers, and the AI is going to make them a whole lot more efficient, but you still need 3 engineers.
You still need 300. Well, you're accomplishing a lot more if you still
Right.
have 3 engineers with the AI versus without the AI. Yeah.
Right, because I mean, like at the simplest level, if you're hiring a back end engineer and a front end engineer for a very small project, 2 engineers, you still have those 2 separate roles, and that's kind of an extreme of that. You can't say, well, I'm going to have the one engineer is going to be split amongst both of them, and the AI will supplement it. In which case, you're probably going to be in worse shape. Or if you say, well, I'll just hire one, I'll do a front end and the AI will make the back end. Well, who's going to verify it? Who's going to custom it? So I do think there's going to be a step back from that. I think possibly at the largest companies, they could slow down their hiring because at that point you do have so many people on related tasks or whatever. But I think for startups, mid-sized companies, I think they're going to find that they're going to need roughly the same number of engineers regardless.
Yeah, that's really interesting to hear, because like I figured that the productivity gains in terms of like the big transformational gains aren't here yet. that, at the risk of putting a percentage on it, that it is maybe more like a 10% productivity boost, just for argument's sake. But even so, that it affects the prospect of that technology having an impact affects forward-looking decision-making, like how much money gets allocated to IT departments and so on. So that capital allocators are already like making shifts based on, do I really need this team of 50 people, or can I get by with 30? And even with allocation, like I was looking at some data on, maybe I can put this up on the screen as well, on investment in enterprise software as a service companies. So that reached incredibly dizzying heights in 2021 and 2022. And it's fallen off by 1/3. So this is some data where it says in 2023, the value of enterprise software as a service venture deals fell by 32%, or the number fell by 32%. The dollar value declined by 33.3% to $73 billion approximately in the US. Now, that's down from 109 billion in 2022, 136 billion in 2021, which admittedly were dizzying heights, where if you look at the prior 5 years before that, the range was between 20 and $58 billion. So we did come off like a very huge mountaintop, but suddenly like there's less capital going to companies that are trying to build software and solve problems with software. And a part of me asked, like, is it that these venture capitalists are saying, like, can I really build a business around the software and assume it'll maintain the sustainable competitive advantage in this economic moat? Or is there a risk that some very widely available large language model can ultimately catch up and perform that same functionality and be available to everyone? I mean, do you see that risk in building a software business?
I guess, but I also like there was that point where, like, again, we had, like, as you said, the mountaintop. We're just like money was being thrown at everything. So there's also just this is just a correction to a certain, like something had to give with that. It was just like ridiculous. Everything was getting funded. But I think I mean, actually, I can't. I would hope that the investors of the world, the venture capitalists of the world, are astute enough. But I know this isn't the case, because there are people who are brilliant in every field, and there are dopes in every field, and there are people who are brilliant in one area who have blind spots in other areas. But at the end of the day, like, what's the LLM doing? It's taking the corpus of all publicly available, and for a private LLM, like I'm sure Google has all of its code, it has all of its code in, like in that LLM, and it's trained on that. And the first thing we have to remember is, if you've ever seen how the sausage is made at any of these companies, my God, how does anything work in this world? Like if you look at like how all of the companies are supposed to go through their rigorous, testing and verifying to get any change in. No, it doesn't happen that way. It's like, can you approve my diff and I'll buy you cookies? I mean, it's like crazy, and there's such fragility in so many software systems. Like to think that these things, these huge software systems work at all, is mind-boggling. Like there is a lot of bad code out there, and basically what the LLM is doing is taking all of this bad code and remixing it. It's like you're kind of like if you basically are building a house, and you have like all of the architectural designs in history, but you're including all of the ones that aren't so good, but may have been popular for some reason at some point in time. You're going to build based on that. That's a shaky foundation. And so not to say, and that's why when my friend use the algorithm, that tree algorithm, they just were able to look at it and say, yes, this is correct. I've tested it. It does what it's supposed to do. And the venture capitalists are going to, I would think that, the good ones are astute enough to say, like, this is what the LLM is doing. It's not generating, it's not true intelligence. It's a probabilistic combination of the stuff that was before, which may not have been so good. And then somebody else will counter, like, well, yeah, but it can write a novel now that like everyone loves. And I was like, well, yeah, except like mass market novels are literally formulaic, like it's just regurgitating the same stuff, and if you're investing in a company, you want the next stuff, so I think ultimately, again, we're also pretty early in this next whatever, on this journey. So, people might be stepping back a little bit and, taking the temperature of things and figuring things out. But I think they're going to figure out, if they haven't already, that it's like the LLM is not going to be the replacement here. We need the next breakthrough, or maybe like the breakthrough that comes, the Skynet breakthrough, 20, however many years down the road, where it does come up with something new and interesting, and then maybe my investments might be riskier. But I don't think we're there. And I think it also comes down to the same thing as the hiring. If the venture capitalists are astute enough to say that, and I think they will be, at least the ones I know, are certainly sharp enough to see this, that it's like, no. The LLM it augments, but it's not gonna reinvent the world. It'll be fine. But if everyone gets afraid and everyone gets scared, but that's a social thing. That's not not reality. Again, that's perception.
Yep. So LLMs are not a silver bullet for every problem. They won't replace every single tool and software tool that's out there and valuable and useful right now. But they are a very useful productivity tool, like we talked about, for software-based businesses, for developers. And let me ask you, from the perspective of a developer, now that you're empowered by this tool, what are the useful skills to learn to really make the most of it? And I mean, like, is it prompt engineering? Is it learning how to architect LLM agents and learning how to have agents interact with one another? What should someone who says, I want to build technology superpowers, I want to leverage large language models to the max, what should they be learning right now?
Well, one is they certainly. I mean, it depends where you are in your career. For somebody who's like early in their career, they're through college or even career changer. The advice that I would say is dive in and play. Go to the existing APIs and platforms and spend a few bucks and get an account and whatever, and start playing and going through all of those tutorials, because you want to be in the market now. That's not necessarily setting you up for long range, success, but just to dive in, it's not that expensive. But I think that the core skills are still problem solving, communication, and I'll talk about the communication in a minute, and research. And how to do those three things. And I might be missing something, but when you say, prompt, when you say, do I need to know prompt engineering? Well, that's communication. You're making a specification. In this case, it's for an LLM versus a specification for somebody else on your team, a specification for a consultant, a specification for a potential, client, to show them what you're going to build for them. And that was always an issue. Even, and at every level along the way. Unfortunately, it's not something that's really taught. And relating, like you talked about, how to architect a custom LLM. And certainly that's a specific skill. But I also think how to architect software is something that an LLM is not going to replace, and again, is not taught in most cases. But I think somebody who's just embarking on the journey, if they can get into a situation to learn that, that's overarching. I think the one of the things that I was really really proud of one of my students. This was right after she graduated from Sty, and she got an internship somewhere. And this was after I had developed a software engineering course, and it was after the first time I'd run it through. And I said, "That's awesome. What are they going to have you do?" And she reeled off like 30 things that she had never done in her life, never had any exposure to in her life, or anything. I'm like, "Cool. So I know you've never done any of that. What's the plan?" And she's like, "I'm going to figure it out," and then then over the course of the internship, we communicated, and I'm like, that made me really proud of her and happy for me, and that maybe I did something right in the way I work with these kids. But it's going back to that other student of mine who said, it's the next thing, or how I said it, that it's like the next level of abstraction. It's if you're learning the basics of problem solving and how to attack problems, and I'm not one of these people that in the computer science realm think you need to learn as much theory as we force upon our kids, and as much in terms of data structures as we force upon our kids, because we force them to memorize a lot of stuff. But we want them to learn how to approach the problems, to develop a solution, and that way, when they get to their, when they're, that's how that other engineer knew. Oh, I can model this problem as a tree, and then I can use this modification of this standard tree algorithm, and then the LLM, it was like bam, 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 and job done. So I think it's learning, the communication for the specification, how to actually problem solve and approach problems, and how to learn on your own, and I think those are the key things, and if you're doing that through a lens of computer science, there's some of that in an undergraduate curriculum. There's a lot of cruft that probably doesn't belong there, but that's another another story. But I think that's what best prepares one. I started to play with this. But let's even go back when I was in college, when I was getting my master's degree. I took an AI course, and it was nothing like it was game search, it was expert systems, it was decision trees, and you don't have to know what these things are, but it had nothing. It was nothing like. I don't know if you recall, but there was a lot of buzz when they released the first MOOCs, the first massively online courses, and one was a machine learning course by Andrew Ng. One was a Sebastian Thrun for an AI course, and so this was 15 years later, 10 years later, after I did grad school, and it totally changed. Like the whole field was totally different. Back when I was in college, if you did natural language processing, you had a big program with 8 bazillion if-then statements, if you recall what those are, conditional statements.
Yeah.
And then fast forward 15 years, like the entire textbook by the same guy was totally different. It's all about statistics and probability. And then fast forward to what we're doing now. And so I've had to kind of relearn all of this and reinvent myself to stay current. And I was able to do this, or I've been able to do this, because I was fortunate enough to have people to help me learn, how to ask questions, how to approach things. And even though I haven't been professionally coding in a while, the reason my code always worked is I was always very good on the communication, on the specification, and I was always, everyone knew what they were going to get from me, how it would integrate into the system, how I would integrate their things in the system. So it's just those core skills.
That's super interesting. And just the value of critical thinking, how to approach problems, and also like how to continuously learn and pick up new frameworks and analytical approaches. That that is at the core what's really valuable, more so than an ability to work with any one tool. Um, with that in mind, can I ask you how, like, wh- what was your framework for shaping the computer science curriculum at the institutions where you taught? How did you go about saying like these will be the building blocks for my students?
The one where I've done it's funny also because like a lot of a lot of educators and schools will contact me, or now I'll see this a lot in the various chat groups. It's like, what curriculum can I use for my school? And and they always like the people would ask me this, and I'm like, I don't know. But if you want to sit down and so we can talk about your school and learn about your school, then we can design something that makes sense for you and your population. Because even though it is always cookie cutter, it shouldn't be. Like this was like I mentioned this a little at the very beginning. Like one of my epiphanies was when my kids were doing really great on these world competitions, and at that point I was just teaching. I was teaching AP Computer Science, which was different back then because it was a more advanced version of it than there is now. And I taught two other courses, and the other courses were, one was a graphics course, which I thought was kind of cool because it would be fun for the seniors, so they wouldn't get too much senioritis, and it combined the computer science they learned in my class, the math they learned, and the physics they learned, and they'd make pretty pictures. So that was kind of that was kind of the only driving force there, and the other was a low level course, but it was just because it was fun for me to teach, and I thought they would like it. But when I had this epiphany, I started to think about, well, like, what about everyone else, and what do these kids need to know? And by that point, when I went to design the intro course, which you took, um, I had started to get feedback. I had started to talk to my graduates about, like what was useful for them and what wasn't useful for them. And so I started to think about, well, what does the student need? And so for that intro course, it was like, well, can I do something where like 80 or 90% are not going to become computer scientists, or not going to go into tech, like not even be adjacent to tech. So what can I give them that's meaningful? What's important? And so that's where I designed the course. We were talking before the podcast, about how you remembered how you did the prisoner's dilemma in there. And that was, like, well, that's something we can explore with computer science, but that's not a computer science topic, and then, so what can I do for there? Plus, maybe inform and inspire that 10 to 20% that, to go on, to do more, and so that was the need there. And then later on, when I designed my software development course, the question was, you have to look at and there was also a question of like, will the students take it? Like in that class that you took, we did Scheme as one of the languages. But when I designed a summer experience for Google, I would never use Scheme. I didn't use Scheme because I knew that like in a summer program, the kids won't come back the next day if they're not happy. Whereas at Sty, I had a decent reputation. I was able to hire other teachers that were popular. So the students would give us the benefit of the doubt until we got over the hump. But you can't do that in the summer program. You couldn't do that in another school. So when I designed my software engineering course or my software development course, I had to think about, part of it was what would attract the students. Part of it would be what would attract the students who are not taking the systems course. And then the other question was, what are they not getting in college? Because whatever I teach them, they're going to have to, like if I just taught the next college course, since there's no AP exam, the college is going to make them take it anyway, which isn't the worst thing in the world, but how can I set it up to fill in the gaps? So it's frequently a question of, and this is where I relied so much on, I cold called people, emailed people with the, like professors and industry people, but I relied a lot on my former students because they were all in the industry at that point.
Mhm.
And there are specifics, but it was always about, like, what do these kids need? And then it was, okay, of what they need, what are they ready for? And what will they have some fun with? And then I would go at the end of the course and start building it backwards to the beginning and see what I would come up with. And so and that approach has served me well. I developed multiple summer programs for my own nonprofit for Google. Advised a bunch of schools, obviously at Stuyvesant. When I was at Hunter, I had to build a couple of programs. That undergraduate honors program I built, my teacher program, and that approach has served very well.
That is really interesting that you weren't just fast forwarding what they will learn in college computer science courses, but like you were filling in some of the gaps and you were helping teach your students how to think. And myself, having taken that intro to computer science course with you, decades later, what's memorable is an analytical framework. Like we were talking before the show, it's where I learned the prisoner's dilemma, and we built these programs that would compete in the prisoner's dilemma and this game theory problem, and then um, it would be one round of competition and then multiple rounds of competition. Then there was the winning strategy was tit for tat, and then tit for tat for forgiveness. Like these frameworks, which now I apply to thinking about geopolitics or certain aspects of business, I learned from that class and remembered 20 plus years later. So I do appreciate the critical thinking that you taught in that class big time.
And if you think about it, and this goes across like all of the classes, like you do, if someone's going to go into tech, they're going to be beaten over the head with enough programming that they're going to learn how to program. But the language they're going to use is probably not the language they're using in college. Like they're going to, things are going to change over the course of the career, but the problem solving is going to remain. And they're going to program in another tool set, in another paradigm. But again, it's all it does come down to the fundamentals in a lot of ways.
Absolutely. Mike, we're over an hour here. And I want to be mindful of your time, but I think we've covered some really good ground on tech education, on the job market coming out of tech programs and the job market you've seen many of your students participate in, and some of these technology shifts with large language models now being the the most hyped shift happening. Um, I want to wrap on a segment that we call the Bodega Corner. It's a little homage to my upbringing in New York. You're a New York guy yourself, and it's where we kind of give our hot takes. So I think for you, I'll ask a question, but frame it in a Bodega Corner way of, well, what were the most rewarding things about being a computer science educator? What do you want to clap it up for in terms of experiences you've had teaching? And then what were the worst things? What do you want to say F out of here to this aspect of being a teacher of computer science?
The the best things about it are not really specific to being a tech teacher. It's if you can, it's the teaching has a lot of downside to it, but like obviously the financial rewards ain't so great. I started on Wall Street, and I worked the long hours and all that, but my first week in teaching was 1,000 times harder. Because like think about like you're and when you work a regular job, it's like, oh, wander in at 10 o'clock, got my cup of coffee, I'll check my email, check the sports pages because we did that back then with the paper, and you kind of like nurse your way into the day. When you're teaching, you're on at 8 o'clock or whenever it is, and you're giving, like I like to say, you're giving 5 semi improvisational shows a day to a captive, hostile audience. And I won't say that you were really hostile, but look, on a nice spring day, I don't want to be there either. Okay, let's be honest. So there are definite downsides. But I think the upside is it really goes to the relationships and the long term. And I've been honored, and like I have a sad story for that, and a happy story. Like the sad story was so I had a student, and his name was Ned Vizzini, and he went on to be a teen angst author. He wrote kind of a funny story, The Other Normals. But he was in my class in the late '90s, and we connected well, and over the years when he became a successful author, he would always thank me for he made ends meet doing web work using what he learned in my class prior, and it shaped a lot of his thoughts. Unfortunately, Ned succumbed to mental illness far too young. And this was a number of years ago. I still get a little choked up. But I sent a letter to his brother Dan, who was also a student of mine. And Dan went on to get his doctorate in computer science and is a computer scientist. And and just talking about how like, even if I didn't speak to Ned more than once a year, he was, really dear to me, meant a lot, whatever. And a few months later, and I just was reaching out to send my condolences. And a few months later, I got a letter from Dan going on about, the ultimate, the kicker in it was, I know you made a lot of computer scientists in your time, but you also made an author. And that really choked me up. Sorry, I'm getting a little. But the other instance was the greatest honor that I've ever had as a teacher, the greatest honor given to me by a former student. And I actually saw him and his family literally yesterday. We were out in Brooklyn for the 4th. And so this is my former student, Josh. And Josh was class of '95, and brilliant young man. Now he's a brilliant, less young man, but ultimately went on to computer science, and I maintained a relationship. I went to his wedding, which meant a huge amount to me. And since then I've gotten to know him and his wife. But he honored me because he made me right leg guy.
Right leg guy.
Oh, so you don't know right leg guy?
I don't.
So let me explain right leg guy.
Please.
Right leg guy is a very special honor. Josh, like me, is a New York Jew. And ultimately, Josh and Amy had little Abraham. And as is the Jewish tradition, 8 days after young Abraham's birth, one must have the bris. And at the bris, the mohel must perform the ritual circumcision. But so as not to be hampered by flailing limbs, one needs left leg guy and right leg guy in order to basically make sure. So Josh comes in here, they come and say, "Hey Z, we need you to basically help out with it." It's like, and then he immediately hands the camera to my wife, Devor. It's like, "Oh, Devor, you take pictures of this." So I'm a little bit horrified, but incredibly honored. But it's these relationships. It's the fact that that we haven't been in touch in like decades, but now we can reconnect. Or I was at another wedding last year of a former student, and the relationships are really, and by having those long-term relationships, I get to see, and this is also something that we spoke about before the podcast, the idea that I don't care if a student goes into tech. I want a student to be happy and productive. I want them to have a happy life and a productive life, not have to worry about, where the rent's coming from and all of that, and just be happy. Hopefully not in an evil way, and I don't care if it's in computer science or anything else. And I hope that I was a positive step along that journey. And by being in touch with so many former students, I get to see their life events, and I get to see, and even if I'm not in touch with them regularly, I get to see, how David and Grace just had their last kid, on Facebook, whatever. And that's really the most rewarding part is to know that, you were a you are a part of all of these people's lives who feel that you have contributed positively to them. Or last one with this, I ran into a student on the street once, and he introduced me to his wife. And I was like, "Wait, you're Z? They talk about you all the time." And I'm like, "This, I'm like, wow, what an honor,
Godfather.
That's something that I don't think you can get in any other profession. And maybe it doesn't happen with all teachers and all students, but I've been really blessed with that. And that means so much to me. Unfortunately, the downside is just dealing with, the Board of Ed, the bureaucracy. I mean, like, I got very, very invested in trying to push computer science. For everybody, ultimately became the CS for All movement. I'd like to think that I had a small role to play in that. But just then you see when things are rolled out badly. I see so many schools that are doing bad CS and so many teachers that are trained to teach CS, but they don't know it. They might be trying really hard, but they just don't know any better. And I see kids not getting what they need. And that's it's so frustrating when you see something could be done better and it can be done right, and it wouldn't be that hard to do it right, but you're powerless, to make that impact. And that's been the huge frustration with my career. I've been able to have a lot of success in various corners, so I'm very happy with that. But I think there's always the frustration, when you see that something else can be done, that's just a no-brainer to you.
But there's the constraint of the bureaucracy. I hear that.
Yeah, and that's just
all right. Well, F out of here to the bureaucracy. That's one takeaway from this bodega corner. And clap it up for building relationships and making an impact in people's lives. Like, we're all on this earth for a short period of time. I do think that the relationships that we make along the way are what we hold on to. When we're on our deathbeds, that's what we consider meaningful. And if we can impact people that we meet along the journey, that's what makes a life well lived. So clap it up for that, and like clap it up, Mike, for the impact you've had in my life and a lot of your students' life. Like, even you and I hadn't been in touch for a long time, but like, I've talked about you with my brother some, and like, there are definitely these nuggets from your class over 20 years ago that I still hold on to and think about. So you've definitely made an impact.
Thank you. That does mean a lot to me.
Awesome. So I think we're wrapping up the interview. I'll ask are there any parting words of wisdom you might want to give for someone who's interested in computer science, interested in starting to learn how to code in today's day and age?
I would say that it is still worth it to, it's very easy to go to these various places online or resources where you can just like easily plug in and start working with these wonderful modern tools. Like you can go to, I think, Hugging Face, and with some very rudimentary programming background, you can get something up and running with almost no background really quickly and functional. And I think that's great when you're building your product. when you're there, you're building your product, use these tools, leverage them. But I think as someone starting out, you want to take a step back and you really want to learn the basics. I think people will still benefit from learning good fundamental programming skills, good software architecture skills. I think if you learn, if you have something of a background in the stat and the math that you need, because then you'll understand, you're not going to understand these really advanced systems to a tremendous degree unless you really do a deep dive and be like, concentrate in AI in college. But you'll know it enough. It'll give you that DS meter, and it'll give you that ability to really understand how you're customizing things. So when you're building your products, and you're making the next great thing, you're not kind of building on this house of cards that you're nervous about. That you understand that, oh, when I use this tool online that runs this algorithm on this data set, or this uses, you know what it is. So take that time. Don't take those shortcuts. Especially if you're young, you have the time, and I think ultimately you'll be better off for it.
Okay, good advice. Mike Zamansky, the Godfather. I appreciate the impact you've made in my life and your students' lives. I appreciate you, and I think we can wrap up the interview here. Thank you so much for joining the Dino Podcast.
Thanks for having me. I love talking shop. It was great to be on with you.
Awesome. Let's be in touch. All right. That's it for this week's episode. Thank you for tuning into the Dino Podcast and for being a member of our community. On this show, I try to cover a wide range of subjects with our guests, from culture, arts, and music to history and foreign policy, all the way to business, technology, and current events. We're independent media, and we rely on your support to keep the show going. If you'd like to support the Dino Podcast, please consider becoming a member for $5 a month. Your membership will give you access to premium content and exclusive episodes, and it will make you a real, true fan, a Dino head. So consider supporting the show, and I appreciate you listening. Thank you for being part of the Dino Podcast community.